You are starting at a request. It looks normal. One endpoint, one query, but then you realize it's not REST, it's a GraphQL. I know what you are thinking. GraphQL is not that, just another API thing. Well, yes and no. See, GraphQL is everywhere these days. Modern applications, mobile apps, microservices, they all use it. And here is the thing that most people don't talk about. GraphQL is incredibly powerful. But with that power comes some serious security implications that a lot of developers just overlook. In this video, we are breaking down GraphQL from the ground up. What it is, how it works, how it differs from REST, and most importantly, the security side of things, the vulnerabilities, the attack vectors, and how you can actually test for them. We will walk through real attack vectors, practical recon methods, and the mindset you need to find bugs that scanners will miss. Because here is the truth. Tools don't find bugs, you do. The only way to find real issues is to understand the technology you are testing. So by the end of this video, you will know exactly how GraphQL works, not just how to use a tool against it. So this is AmrSec, go get your coffee ready and let's dive in.
Caido has enough content.
Me, as this is
Before we jump in, I want to give a quick shout out to an incredible research I recently read on Yes We Hack by Alex Broman. It's called The Minefield Between Syntaxes, Exploiting Syntax Confusion in the Wild. This research dives into advanced exploitation techniques using syntax difference across different systems and parsers. It's really solid work that shows creative payload crafting and real-world bypasses. So if you are into bug bounty or research, you need definitely to check this out on Yes We Hack. That being said, let's dive in. So first things first, what actually is GraphQL? GraphQL is a query language for APIs. It was developed by Facebook back in 2012 and open sourced in 2015. Now, the name might make you think it has something to do with databases, like SQL, but it doesn't. GraphQL does not interact with databases directly. Instead, it sits as an API layer between your client and your backend services. Think of it like this. Your client, whether it's a web app, a mobile app, etc., sends a GraphQL query to the server. The server then processes that query, fetches the data from whenever it needs, whether it's database, REST APIs, microservices, and returns exactly what the client asked for. No more, no less. And that's the key difference here. With the traditional REST APIs, the server decides what data you get. You hit an endpoint and you get back a fixed response. Sometimes you get too much data over fetching. Sometimes you don't get enough under fetching. And if you need data from multiple resources, you are making multiple requests. GraphQL solves all of that. With GraphQL, the client is in control. You define exactly what data you need and you get it all in single request. One endpoint, one query, all your data. So why does this matter? Well, for developers, it's amazing. It's faster, it's more efficient, it reduces network overhead. But for us as security testers, this flexibility introduces some interesting attack surfaces. And that's what we are going to explore. Alright, so let's see this in action. I want to show you the difference between REST and the GraphQL in a quick scenario. Okay, so let me run the server right here. And right here, it's just a quick API. It has the REST API running on the port 3000 and the GraphQL API runs on 4000. So let me just go right here to this API. And right here, you will see that we cannot get slash. So this is basically a REST API. So right here, if we want to get the users, we can just go to, for example, /API/users. And this will give us all the users right here. We cannot just ask for specific details for all the users. We get all of them. We cannot control that. So if you want only the data for the user ID 2, we have to go to /API/users/2, and this will give us our users data. Okay, cool. But right here, the thing is that we cannot control anything. We get a fixed response. So let's say that we need this user's posts. So what we have to do is go to API/users/2, which is the ID, and after this posts. And this will give us the user 2 posts, okay, which is only one post. So what I want to tell you right here that we have created 3 requests. First request is to get all the users, and that's normal. The second request is /users/ID to get the user details. After this, when we tried to get the user posts, we requested another endpoint, which is /ID/posts, so we can get the user posts. And right here, all the responses are fixed. So that's it for REST. But right now, if I go to GraphQL, it's different. So here is my GraphQL server. Let me just click here. So I go to Studio. This is Apollo Studio. It just runs on my local API server. So let me just remove this right here. As you can see, we have some fields right here. You don't have to understand all of this right now. What I want to show you is right now, if I added query like this one, it's a very simple query, but let me just explain it for you. The query is basically user, and we need the user ID 1. So this will give us the user ID 1. Let me remove all of this like this and just run this. Once I run it, it will just give me the data, and inside the data there is user. And the user, of course, it is the ID 1 because we asked for that, and it's giving me only the name. So right now it's literally giving me what I asked for, no less, no more. Okay, so check this out. If I just continue all my queries, so right now I need the user ID 1, I need its name and its email, and I need the posts for this user. But right here we have something pretty cool. We don't need all the posts data, we need only the posts title and content. So when I run this query, it will give me the user details, which is name Alice, and the email is alice@example.com, and it gives me the posts also, but it's only giving me the title and content for the posts, which is right here, hello world and welcome to GraphQL API. So you saw the difference. REST forces multiple endpoints and fixed payloads, but GraphQL gives the client control and one flexible endpoint. That control is powerful. And it's also when problems start when the server does not limit or check what the client can request. Alright, now that you have seen GraphQL in action, let's break down how it actually works under the hood. Because if you want to test GraphQL security, you need to understand its structure first. Let me go here to schema def and remove that. Alright, so everything in GraphQL starts with the schema. The schema is basically the blueprint of your API. It defines what type of data exists, what fields they have, and how they relate to each other. So here, for example, we have 2 types, user and post. A user has an ID, name, and email, a list of posts, okay? And a post has an ID, title, content, and author, which is user. So I want you to notice the scalar types here. ID, string. These are the basic building blocks. GraphQL has 5 scalar types: integer, float, string, boolean, and ID. The important thing to understand here is relationships. A user has many posts. A post has one author. This is how GraphQL connects different pieces of data together. This is the schema, basically. Now, how do we actually request this data? Through queries, right? So let me get back right here to the Explorer, and here we have the operation which is the place we just write the query on and the response. So let's take this query as an example. This is a GraphQL query. We are asking for a user ID 1, and we want their name and email. That's it. The server will return only those 2 fields. So when I run it, I will get only the name and the email. But here is where it gets powerful. Nested queries. This query, for example. So when I run it, we will get this response. Now we are requesting the user, their posts, and for each post, we want the author's name. You can nest as deep as you want, and this is actually one of the attack vectors we will talk about later. Deeply nested queries that can cause denial of service. So here it's pretty simple. We have the user ID 1, we need their name and email, and here we got them. And after this, we are asking for the posts, and we are asking for the post title, and we need also the author, but we don't need all the author data. We only need the name of the author, which what we exactly got right here. So we will only get these fields. That's pretty much it for the queries. So far, we have been hard coding values directly into our queries, but in the real applications, you use variables. Let's take this query as an example. And after this, we pass the variable, which will be something like we here the variable have the user ID. So we will add the user ID right here, and the user ID will be 1. Okay. So right here, you will see that this is variables where we pass our variables, and this is our query. So when I click get user, what's going to happen is going to give me the user name and the email because we are asked for that. But right here in the ID, it's just getting what variable being passed to the query. And right here we have it is ID1. So that's it. But why does this actually matter for security? Because right here, variables are where user input comes in. This is where injection attacks, fuzzing, and brute forcing happens. If you are testing a login mutation, you are manipulating these variables. So queries are for reading data, but mutations are for writing data, updating, deleting, creating, whatever. Think of it like queries are kind of like GET request. They just get data, but the mutations, they like post, bot, update, patch, delete, all these requests, okay? So let's take this as an example. This is mutation. And right here, it's pretty simple. It's create post, okay? And this post, we will give it some data such as the title, which will be new post, and content will be, this is content. And after this, we need to return the post ID and title. But of course, we have to remove this variable first. And right here, if I just send this, I will get an error because there is nothing called create post. But here is the thing. If I get back to the schema and scroll all the way down, I will see that in the mutations, we have add user, add profile, add post. So here it is. It's called add post, not create post. Okay. So I will get back and I will just change this to be add and post. Okay. Once I do this and send it one more time, I will also get error. And right here, you will see that we have different error. I don't need to read an error because in the schema, also we saw that the mutation add post requires title, content, and user ID. So I have to define the user ID. I can do this by just adding and user ID will be something like maybe 1. Okay. So this is wrong. It have to be D like this. So once I click run, you will see that right now we have created a post and it's returned the data for the post and not any data. It returned only the ID and title. If we added here something like content and send it, you will see that it returned also the content. So that's it. This creates a new post and returns the ID and title and the content for the newly created post. Mutations are where you will test for authorization issues, CSRF, and injection attacks. And last thing we have fragments. They are basically reusable pieces of queries. So let's take this one for example. Basically, this is just for keeping your queries clean, but fragments can also be abused in certain attack scenarios, especially when combined with circular reference. So right here, we have the fragment of user info, which have only the name, email, and in the query, we used this fragment so we keep our query clean. And in the post, we just returned the title. We can also add here something like, I don't know what we have, maybe the ID, I think, and send it, and you will see we also have the ID here. So that's it. Now you understand the core structure of GraphQL. Schema defines the data, queries read it, and mutations modify it. Variables handle input, and fragments keep things organized. This foundation is crucial because every attack we're going to talk about exploits some aspect of this structure. So now that you understand how GraphQL works, let's talk about why this matters for security. Here is the thing. GraphQL gives a lot of power to the client, and whenever you give users power, you create potential security issues. Think about it. In REST, the server controls everything. You hit an endpoint, you get what the server gives you. But in GraphQL, the client can request whatever they want, however they want, as deeply nested as they want. So, if the server does not have a proper control in place, rate limiting, query complexity analysis, depth limiting, authorization checks, attackers can abuse this flexibility. We are talking about denial of service, information disclosure, authentication and authorization bypasses, rate limiting bypasses, CSRF attacks, and so much more. Each of these attacks exploits a different aspect of GraphQL's design, and the only way to find these issues is to understand how GraphQL works under the hood, which is exactly what we just covered. So let's start looking at how we can actually test for these vulnerabilities. Alright, first step in testing any GraphQL API is actually find it. Sometimes it's obvious, the application tells you it's using GraphQL, but sometimes you have to discover it yourself. GraphQL typically lives on specific paths such as /GraphQL, /GraphQL, /API/GraphQL, and so on, and also /playground. So you can manually check for these, or you can use directory brute forcing with a GraphQL specific word list. And you can do so by just going to your machine and use fab to do that. Let's say our word list is graphql.txt, for example. And after this, you have to define your URL, which is https://example.com/fuzz right here. And that's pretty much it. It will just go through all the word list, and once it finds something, it will just give it to you. So this is basically to find the GraphQL endpoint through directory fuzzing. But here is a pro tip. If you are testing an application that has a front end, what you have to do is just open your browser and open the developer tools. And before you send any request, go to the network tab and send your GraphQL query, or maybe edit your profile or view any details. And in the network tab, you will see the endpoint right here. Or you can just check your HTTP proxy. You will also see it there. But here you have to make sure that you are looking for a post requests with a JSON bodies contains a query or mutation fields. Okay? So that's it for identifying the GraphQL path. Next step is fingerprinting the engine. Once you find the GraphQL endpoint, the next step is figuring out what's running behind it. Different GraphQL implementations have different security features and different vulnerabilities. This is where a tool like Graphql comes in handy. So before I use the tool, let me just open right here GraphQL itself and test on it directly. Let's say we have here a test API we can use. So as you can see, here is our test API. So right now I don't know the GraphQL endpoint, and as I said, we can just open the dev tools right here and open our network tab, send our query, and as you can see, we have it here. That's our GraphQL endpoint, okay? So I will just copy this and I will get back to my terminal. And right here, Graphql usage is pretty simple. And before I dive into that, I want to mention that all the tools I will show you, I will just use the basic and simple usage for it. I will not dive deep into any tool. So I have here Graphql, and if I just ls right here, I will see the files. So I have to do just python 3 main.py, I think -, and I will add my GraphQL endpoint, which is this endpoint. And after this, I will just add something like -f. Once I do this, it will just start checking for the GraphQL that's available on this endpoint. And as you can see, it's attempting to fingerprint, and I will just wait for it. And as you can see right here, it's told you that the GraphQL engine is Apollo and the attack surface matrix is right here. You will see that also the technologies is JavaScript, Node.js, TypeScript, and the homepage of the main GraphQL engine is here. So Graphql fingerprints the GraphQL engine by sending a different types of queries and analyzing the responses. It can identify if you are dealing with Apollo, Graphene, Hasura, or any other GraphQL implementation. So why does this matter? Because each implementation has its own security features. Some have introspection enabled by default, some have bit rate limiting, some are vulnerable to certain types of DOS attacks. Knowing what you are up against helps you to prioritize your testing. So now we have found the GraphQL, we know what engine is running. Next step is getting the schema. So the schema is everything in GraphQL. It tells you what queries exist, what mutations you can perform, what fields are available. It's basically a map for the entire API. The easiest way to get the schema is through introspection. Introspection is a built-in GraphQL feature that lets you query the schema itself. So right here, if I just deleted all of this and just added this and run it, boom, there is our schema. You can see all the types, all the fields. This is literally gold for us because now we know what exactly the API can do. But probably you don't want to read through raw JSON. That's where visualization tool come in. GraphQL Voyager. So GraphQL Voyager takes the introspection data and turns it into interactive graph, which let you see the relationships, all the connections, and you can explore the API visually. That makes it easier for you to understand the attack surface. I will not show you GraphQL Voyager right now. I will just skip it and show it to you when I dive into Caido itself. So that's the introspection, and through it we were able to get the GraphQL schema. But what if the introspection is disabled? A lot of production GraphQL APIs disable it for security reasons. So when we try to test an GraphQL API and it's a block, that doesn't mean we are out of options. There are many ways to bypass this or reconstruct the schema. First, you can switch from post to get. Sometimes the security controls only check post requests. Second, you can regex bypass it, adding new lines, spaces, comments in your introspection query to evade basic filters. And third, you can exploit error messages, sending invalid queries, and the server might leak field names in the error response. And fourth, you can brute force field names using a tool called clairvoyance. I don't know what's called, so let me show it to you. So right here, I will just go to my terminal again. Let me just clear this screen. And the usage for this tool is pretty simple. I just call it, I give it the GraphQL endpoint. Okay, inspect, all right, send. Okay, and after this, I just defining the output file, which is called schema.json, for example. So basically, the tool uses a word list to guess field names. It sends a queries with the potential field names and analyze the responses. Over time, it reconstructs the schema even without introspection. So basically, this takes time, but it works. And once you have the schema, you can load it to Voyager, like what I'm going to show you right now. So whether the introspection is enabled or not, you can get the schema. It might take more work, but it's a doable. And once you have it, you are ready to start testing. Let me close this and get back to my server right here. Now we get to the fun part, the attacks. Let's go through the main vulnerability category in GraphQL and see what they look in brackets. The first thing we're going to talk about is denial of service. GraphQL is vulnerable to denial of service attacks because of how flexible it is. You can craft queries that are so complex, so deeply nested that they overwhelm the server. So let me show you how this looks. So let me back right here. Let me remove this fragment completely and leave my query like this. And I think if I just send it like this, it will just give me an error because there is no fragment like this one. So we can add here something like ID, okay, and name. And let me just give this some tabs like this. And when I run it, it will just give me the ID and name and the posts. What we can do is basically remove this ID and name completely and copy these posts. Come right here inside these posts, okay, and paste this nested query one more time. So let me do this, okay, and this. If I run it, it will not just run right here because I don't have something called posts inside the post. So this query basically keeps going deeper and deeper. If there is no depth limit, this can cause server to run out of memory or CPU trying to process this. So this is basically what's called circular queries, okay? But there is other thing called alias abuse. If I just come right here and write name, what this gonna give me is going to give me the name of the user, right? So let me just close this right here. And if I just run this, it's going to give me the username. And if I just write here, user1 is basically the user ID 1 name. So right here, we will see that the user1 is the name. So this is called alias. What we can do is abusing this alias and just paste it multiple times like this. So basically, aliases lets you run the same query multiple times in a single request. So if there is no limit on aliases, you can overload the server with one HTTP request. Tools like Graphql Attacks can automatically test for these issues. So if I get back right here and just like hit Control-C, go to Graphql-Attacks, and here I will just like ls, okay? So I can just Python 3 Graphql Attacks and I will just give it this URL. And once I hit enter, you will see that it's telling you that there is alias overloading, there is directive overloading, there is field duplication, field suggestion, and get method query support. So that's what it gave us right now, but that doesn't mean that this is 100% correct. You have to check it manually by yourself, but I just told you how you can test it using Graphql Attacks. And also there is BatchQL, specializes into batch query attack. So let me just get back right here, go to BatchQL and ls, and let me just run Python 3 batch. Okay, this is Python 4. Oh, come on. Batch.py, and right here I will have to add -e and give it my endpoint. You will see that failed to perform. Okay, so let me just zoom out a little bit. You will see that introspection request was successful. So the introspection basically is enabled. It's failing to perform CSRF check, and that doesn't mean that the CSRF checks are disabled, because at the top it's just told you that this is enabled. That's why I'm telling you, you have to check this manually, and you will see that it's telling you that query name based batching is possible. So basically these tools automated the testing, but the key is understanding what they are doing so you can test manually when you need it. That's basically it for the denial of service. Right now, let's dive into rate limiting bypass. So traditional rate limiting counts the number of HTTP requests, but with the GraphQL, you can stuff hundreds of operations into one single request using aliases like what I just showed you. Let's say that the server limits you to 5 requests per minute. With aliases, I can make one HTTP request with 100 queries inside it. So let me show you how this works. So let's say this called, okay, let me do this attempt 1, for example. Let's say that this called login, and inside the login we have the username, let's say admin, for example, which is our input, and we have also the password, which is, let's say, password, okay? And right here we are asking for token. So if we try to do this like 100 times, it will just block us because of the rate limit. But we can bypass this rate limiting by using the alias right here. So we can just copy all this line and paste it like, let's say, 1,000 times, okay? So the rate limiter sees this as one request, but the server processes the 100 login attempts. This is how you bypass rate limiting with GraphQL. And the next thing we have is authentication and authorization issues. Authentication and authorization bugs are huge in GraphQL, and the most common issue is missing field level authorization. And let me show you how this is done. So let me get back right here and ask here for the name and the ID and the email, for example, okay? So when I send this, it's going to return the name and the ID and the email, okay? But there is some specific fields that they are not supposed to be queried, or they are not supposed to be provided to the client when the client asks for it. Something like, let's say, the password, for example, okay? Or the social security number, or whatever thing that's supposed to be really sensitive and the user is not supposed to get it. If this return data That's a vulnerability. The server should have checked if we are authorized to access that user sensitive data. Okay. And also we have something like brute forcing credentials. So if we want to brute force a credential in GraphQL, we have to use something called CrackQL. And the CrackQL usage is pretty simple. So let me clear the screen right here and go back and go to CrackQL. And right here, I will clear the screen one more time. And let me get back right here and copy my API endpoint. Let's say this one, for example. Right here, the usage of CrackQL is Python 3. And after this, the file called CrackQL. After this, we have to define our endpoint, which will be this one, for example. And after this, we have to give it some arguments to use. For example, what we want is basically login.graph, and our word list basically is, let's say, user and passwords.csv. And after this, we can add -b100. So CrackQL batches your brute force attempt using aliases, by passing rate limits and making attack much more efficient. So that's it for authentication and authorization issues. Right now, the next thing we have is information disclosure. And information disclosure in GraphQL happens when the API leaks data it shouldn't. That can be through, let's say, field guessing, for example. If I get back to this API and in the field, I have asked for something like name, but instead of E, I will add S. So if I send this, it will tell me, cannot find the query name on query fields. Did you mean name? So right now, this is called field suggestion. And that's basically when we write something wrong, but really close to what's already there. And the server responds to us with the correct field name. So when I add it like this and send it, it will just give me the data. So this is called field suggestion. And sometimes fields that should be restricted are actually accessible. And also the information disclosure could be through debug errors. So exactly like what I told you right here, when I sent this, you see that the server returned a full stack traces showing internal paths, GraphQL version, maybe even the database query. And this is information leakage. So we can also find information disclosures through query tracking. Some servers enable tracing, which adds execution time data to responses. This can leak information about the backend architecture. Okay, so that's it for information disclosure. The last thing we have is CSRF in GraphQL. And let me show you how this is done. So to show you how we can do a CSRF in GraphQL, I have to open my proxy. So right here, this browser is proxied to my Caido. So if I just send this request, you will see that we have the schema right here. And if I get back to my Caido, you will see that we have the post request right here and the schema. So I know that in this video, I showed you all the queries, how you can use them and so on in the studio. But right here, this is how it looks like. Okay. So we have the schema, we need the type, name, fields, and the \n means like enter, brief line, okay? Right here, this is exactly this. So CSRF in GraphQL is possible when the API accepts GET requests or form encoded POST requests and relies on cookies for authentication. It has to rely on cookies. For example, let's say that we have here something like basically a mutation, okay? And this mutation have within it like something called delete account, which is basically deletes the user account, and we have only to ask if it's success. We don't have something like this in this API, but I'm just showing you how this looks like. So if I send this request, you will get an error because there is nothing like this. But let's say that this is how we delete our account, okay? So I have sent this request so I can get it in the proxy right here. We'll see that we have it, the mutation, delete account, and we need success. If we want to try CSRF right here, we're going to send this to reply. And after this, we will just remove this, and also this one, okay? And we will make it something like where query equals, mutation. And we have also inside mutation, delete account. And we need the success state, okay? So let me just something like this. Once we get it, we will just add it right here. So it will be get request, and once we send it, there is a syntax error because we already have a syntax error. So when we send this, you will see that the GraphQL server replied. That means it accepts the get request. So by simple request like this, we can just implement a CSRF attack to delete any victim's account. Now the attacker can trigger this with simple link. If the victim is logged in and clicks on it, their account gets deleted. You can also try to change the content type to be something like XWWW form URL encoded and see if the server still process it. So basically these are the main attack categories in GraphQL. Each one exploits a different aspect of how GraphQL works. And if you want me to do a deep dive on each of these with full exploitation walkthrough, comment part 2 below and I will make it happen. So I was waiting for this part of the video, and right now I'll show you how you can just do all this work inside your Caido. What you need is your browser and your Caido. So let me show you that. So this is our ad, and once I send this query, we got these data, okay? And again, if you take a look on this, you will understand it because I just told you. When I send this query, it just given us response, and that means it sent a request to our Caido right here. If I open that request, you will see that it looks really bad. To do exactly what I'm going to show you, you have to make sure to go to plugins, and after this go to community and make sure that GraphQL Analyzer is there and installed. Once you install it, it will look like this, okay? Once you have a GraphQL request in your HTTP history, you will see that there is something called GraphQL. Once you click on it, you will see that right now this formats the query for you so you can read it. So you will see that we have the query and the query name called my query. We have all the films after this, nothing. And you know, right now you can read it because right here it's just using \ns and so on. So this is the first thing. Second, we have variables. So if there is any used variables, it will be provided here. And in the request info, you will see the operation name and all the important details. So this is not useful until now, it just formats the query. But here is the thing. If I right click right here and go to plugins, after this go to GraphQL Analyzer and I click scan GraphQL endpoint, what's gonna happen? The GraphQL Analyzer will scan this GraphQL endpoint, and if the introspection is enabled, you will see right here that it is successful. And once I click on it, you will see right here that we have all the schema. We have the films, the persons, and we have all the data, all the schema for this GraphQL API endpoint. And if I just go to the JSON schema, you will see right here, which is awesome, okay? But this is not it. I told you that I'm going to tell you about GraphQL Voyager, right? So right here, it is scanned, and it's the schema explorer. We can see we have this session. But if I just open anything right here and click on this icon, you will see that it will redirect us to Voyager right here. So let me just go to Voyager and click on the session, and that's it. That's it. Right now you can see a complete visual of how the schema looks like, what's connected to other, and basically everything you can see right here. Let's say for example I'm looking for the products. When I click on it, it will just autofocus a hair color and so on. So this is what GraphQL Analyzer Voyager looks like. We can, for example, come right here and hover on this line to see where it goes. It goes to the page info. So that's pretty much it. We have here all the queries and we don't have any mutations, and you can see that right here. It's just an empty, and that's a GraphQL Voyager. But let's talk about GraphQL Attacks. So if I just get back right here to the Explorer or maybe the HTTP history and click on this shield, it will send it to the attacker, okay? GraphQL attacker. And right here you will see that there is some basic attack vectors right here. We can just select all of them and execute the attack. And once we do this, it will just start attacking the GraphQL endpoint with the headers that's already have. And if there is finding, it will tell you right here. So the first thing is schema introspection, and you will see right here we have added the query, introspection query, and the schema we need the name, and we have all the schema right here. You'll see here the attack data, the attack payload, and the attack response. And in the security finding, you'll see that it's telling you, hey, there is GraphQL introspection enabled. You want to create finding? If you click, it will just create a finding right here from GraphQL Analyzer explaining the finding that it's found. And if I get back to GraphQL Analyzer and go to the query depth limit, for example, you'll see it did the same. And right here we have a finding, and it does not find anything else because these are the only available attacks until now. The great thing right here is, let's say that we found the schema right here. You can just click on this arrow icon and it will just send it to reply so you can retest on it. And yeah, that's pretty much it. We just did all the things again like in 5 minutes inside Caido, but these foundations are really important to understand. So this is the power of integrating your testing tools into your workflow. But remember, the plugin is just helping you to execute tests faster. You still need to understand what each test is doing. So this is the workflow. Use tools to speed up reconnaissance and initial testing, but always do manual validation and creative testing. This is where real vulnerabilities are found. Alright, so we have covered a lot of tools in this video. These are all powerful tools that makes testing faster and easier. But here is what I need you to understand. Tools are assistants, not replacements. A tool can tell you that introspection is enabled, but it can't tell you which field in that schema are the most interesting to test. That requires understanding the business logic. A tool can tell you that batch queries are allowed, but it cannot craft the perfect brute force attack for the specific authentication flow you are testing. That requires understanding the application. Also, a tool can find low-hanging fruit, but the high-impact vulnerabilities, the authorization bypasses, the business logic flows, the creative attack chains, those requires human intelligence and deep understanding. This is why I spend so much time in this video explaining how GraphQL works, the queries, the mutations, the variables, the schema structure. Because once you understand that foundation, you don't need 1,000 tools. You can test GraphQL APIs with nothing but Caido reply and your brain. You can look at schema and immediately identify which fields are sensitive. You can craft a query that tests authorization in ways no automated tools would think of. You can combine multiple attack techniques because you understand the underlying mechanics. That's the difference between someone who runs tools and someone who actually finds bugs. Understanding. So yes, use tools, use GraphQL Analyzer plugin, use whatever makes your life easier, but never rely on them completely. Always dig deeper, always test manually, and always think creatively. Because at the end of the day, tools don't find bugs, you do. So that's GraphQL. We have covered what it is, how it works, how it compares to REST, the entire structure, schemas, queries, mutations, variables, fragments, and then we went into the security side, reconnaissance, schema discovery, and an overview of the main attack vectors, denial of service, rate limiting bypass, authentication issues, information disclosure, and CSRF. Now, this video is a comprehensive overview, not a deep dive into each attack. If you want me to create a part 2 where I go in depth on each vulnerability category with a full exploitation scenarios, real targets, and advanced techniques, just comment part 2 below. If I see enough interest, I will make it happen. In the meantime, I highly recommend you practice. There is a project called Damn Vulnerable GraphQL Application. It's specifically designed for learning GraphQL security. Set it up, test everything we talked about today, break things, and learn by doing. Also, many public APIs use GraphQL. GitHub, Shopify, Stripe, Yelp, they all have GraphQL APIs you can explore. Obviously, test responsibly and within their terms of service. But these are great for understanding how real-world GraphQL implementations work. So, if you found this video helpful, do not forget to like, subscribe, and hit that bell icon for more cybersecurity content. And if you have any questions, feel free to drop them in the comments below, or you can reach me on Twitter. Until next time, stay curious and stay secure.